Assalamu alaikum, dear students. Welcome to a special lecture on research. I'm Dr. Pervez Ahmed. This lecture is basically designed for a new researcher. I mean, the people who start research are trying to start their thesis. So, this lectures we will basically trying to make the new researcher understand the basic meaning and the concept relevant to the research. So first of all, we need to discuss or we need to define the research. Right? What is mean by research? So the argument we will start from the questions. What is research? So what is research? I mean, this is the question that every researcher have its mind whenever he or she's come to do the research, or whenever he or she's come to do or start their work for their thesis for an MPhil, MSc or PhD degree. So let's have some formal definitions for the question that what is research. So research is what we do when we have a questions or a problems we want to solve. So normally, whenever you come to the lab, or whenever you start to have your thesis, an MPhil or an MSc and a PhD, so you are given a problems and you are being asked to do the work on that problem. So normally, at the first instant when we define the research, so we say that it's been the strategy or it's been the the plan you're trying to do to solve that specific problem. So you may already think we know the answer to our questions. I mean, sometimes you think that your topic, your research topic is quite easy, and you already have the answer for that in your mind. But we may think the answer is obvious, common sense only. I mean, when you are given the study, so sometimes you think in your mind that the problem that you are being given is quite simple, and you will be able to easily do that in that specific amount of time. But until we have subjected our problem to rigorous scientific scrutiny, our knowledge remain little more than the guesswork or at a best intuitions. So this why we do a lot of work. We perform the experiment again and again. We test the results. So until unless we are not satisfied with the result, so we cannot say. And even when you perform the experiment, so that experimental results are you trying to put on a piece of a paper, and that's being forwarded for the expert in the field. And until unless not being acknowledged or being accepted by those expert in fields, you cannot have the exact answer whether what you have done is exactly what you were needed or not. So you need to do the things. First priority is to formulate your questions. I mean, you're given a question on a piece of paper, or maybe directly by your supervisor, or maybe by your instructors. So the first priority is to formulate your questions, and then figure out how you are going to answer it. I mean, you make your strategy that how you need to solve, or you should proceed for answering that particular question or that particular problem. So you have to ask yourself that how have other answered it. I mean, you go to the literatures, and the literature you do a rigorous study, relevant study, and you try to look for the answers. I mean, so you trying to search for that you trying to find out that there might be other people who have already worked on it. So first of all, what you need, you have to go to the literature. You need to find that how many other people have answered it, and in which particular pattern they have answered it, and what kind of experiment they have performed to answer that particular questions. Then you should need to ask yourself that how does your proposal fit and what others have done. I mean, normally you have your own proposal for doing your specific work. So you should also compare your proposals with other people's work. I mean, there might be people in your field who have already done a lot of work on that proposal. So you should differentiate your proposals or your ideas from how other people's have done that particular work. And also how well you know when you have answered it. I mean, you should also know about that. you should search for the specific logic as well. Then you can present your answers. Your answer, you can present that to the expert, or maybe to your supervisor, or maybe your instructors. So there is some classical scientific methods one need to do whenever he or she start doing the research. That consist of the following step. That is, first of all, one should have observations of some phenomenon. So these phenomena may be systematic, occasional, or accidental. I mean, this is the first thing you do when you're trying to start a research. That is, you need, or you're being asked to observe a phenomena. And just like we mentioned, that phenomena may be a systematic, or maybe occasional, or accidental. From that observations, you can get some idea of an explanations that we call the hypothesis. I mean, by that, you do the induction, conjecture, intuitions, or guesswork. I mean, when you observe a phenomena, so you get some idea or explanation for that in your mind, which we call hypothesis, which normally consist of an inductions, conjecture, intuitions, or guesswork. And that is the piece of, an explanation or the piece of idea which is usually informed by related work. You get the guess, and for that guess or guesswork or hypothesis, you again consult the literature or the relevant work from the people who have already done a lot of work in that field. And at the end, at the third step, which is the most important, that is testing of the hypothesis. Test of the idea you have get or you have developed in your mind. So once you test and that idea, then you need to revise that again and again. To further confirm that whether it's been true or false. So the question is, you develop something. You first of all, you observe something, then you get or you develop an idea that basically you're trying to explain what you have observed. So we call that idea that you develop by observing something, we call that hypothesis. So what is hypothesis? So by hypothesis, we mean that it is something that we call the probability of a research. That can be true, that can be wrong. You should assume in your mind that nothing is certain. The exception that proves the rules. Scientific truth is actually usually a statement of what is most probable given the currently known data within the given framework. Statistical techniques try to help us exact shows extents to which our results really do support the hypothesis. So the question is, what is a hypothesis? Just like we mentioned on the previous slide, that first of all, you are doing something, and that's something you try to observe, and after observations, you try to develop an idea for the possible solutions. So that possible solution we call hypothesis. The possible idea you develop by observing something. So here we have a formal definition for the hypothesis. A hypothesis make a predictions of the expected outcome in a given situations. And you normally develop the hypothesis basis on your observations. So it's usually how the manipulation of the independent variable will influence the behavior of a dependent variables. That is the thing you need to do while you're trying to develop a hypothesis. So the hypothesis is tested in experiments. Once you develop a hypothesis, you observe the situations, uh, you observe that there is a problem, and just based on your previous knowledge of the relevant work, you do some predictions, and on the basis of that predictions, you design to do some experiment in order to verify whether it's true or it's false, or it's in between the true and false. So experimental design ensures that what you are doing is genuinely responsible for the result. So during that experiment, first of all, we define the variables. We define two variables normally, that is a dependent and independent variables, and we're trying to avoid the extraneous variables, or we have to control that variable in order to avoid the unexpected results. I mean, normally whenever we try or whenever we try to test our hypothesis, so normally we define our variables, and we try to do the thing according to those variables. We trying to avoid the unwanted parameter or the unwanted variable that we call extraneous variables. So we should need to control them. So experiment is what we do when we try to check whether the hypothesis that we develop is true or not. So what actually we do in the experiment? So at the experiment, in the experiment we do some real work. uh, During that real work, I mean, we test basically the hypothesis. So the hypothesis is shown to be probably correct, but by correct, we cannot, we do not mean that it should be 100% true. And if it fail, it could be because the hypothesis is wrong, or the other possibility is the experimental design is faulty. I mean, this is the possibility that how, I mean, we checked our guesswork, we check our hypothesis. I mean, for checking the hypothesis or for testing our guesswork, we normally do the experiments. But we remember, we do not get 100% results in the experiment. So what if we do the experiment? Sometime it's possible that we will get our required results. But even if we are fail or we are unable to get the required results, so it do not mean at the first guess that your hypothesis is wrong. I mean, it's possible. I mean, you can ask yourself, it's possible your hypothesis or your guesswork is wrong. I mean, maybe you have not predicted, you have insufficient knowledge of the literature, or you have not done the proper work needed to exactly predict the outcome or the requirement for the work you were trying to do. And in the second action is you have to relook your experimental designs. I mean, it's possible that I mean, there might be nothing wrong with your hypothesis, but it's possible that the experimental design or the experimental setup that you have developed to test your hypothesis, it might be wrong. We might have some mistake, or we may have some fault that in that experimental design. So first of all, I mean, what I guess, I mean, you have to revisit your hypothesis. You should check your variables. I mean, if possible, you should also visit. I mean, the previous work. If you make sure, I mean, if you are sure that your hypothesis is not wrong, your hypothesis, I mean, you should say that I should give a second try for testing your hypothesis. So then you better to focus on your experimental designs. Maybe you have not designed the experiment in the way you should. So once you redesign your experiment, so maybe it will work. So based on that, we have certain type of the hypothesis. The one we call the non-hypothesis. Uh, we will try to explain non-hypothesis and the alternative hypothesis in this slide. So when you try to redesign your experiment, so we remember experiments are generally set up to demonstrate or support a hypothesis. I mean, when we try to do the experiment, or when we need to do the experiments, whenever we are trying to check a hypothesis, whether it's true or not. So for that, we do the experimental work. So based on that, we have two different kind of hypotheses. The first is we call the null hypothesis, that we denote by H naught, is that any observed change in the behavior are due to chance. I mean, that's what we believe in the null hypothesis. So what is the null hypothesis? The null hypothesis that we denote by H naught is that any observed change and the behaviors are due to chance. And then we have the second hypothesis that we call the alternate hypothesis, that we denoted by H1, is the hypothesis you are trying to demonstrate. I mean, one is that is due to chance, and the other is the alternate hypothesis, that is you are getting by trying to demonstrate.
So usually the best you can do is to refute H naught, thus showing that H1 is probably correct. I mean that's this what normally we do. So with a measurable degree of likelihood, that is statistical significance. So where do hypotheses come from? I mean the questions that we have to some extent already we have justified. So again, we're trying to make it clear that where do hypotheses come from. So be remember that the hypotheses do not come all the way by itself. That is not usually 10 years. I mean, the hypothesis, I mean, it's not something that you can get all by itself. I mean, you have a lot of work. I mean, you have the idea. I mean, a great extent or great amount of work from the previous literature. You have a lot of interactions with other researchers, especially, I mean, who are working at your lab. You having discussion with them. So, I mean, when you come, you to develop an idea or a guesswork. So, it's mean that at that particular instant of time, you are a good piece of an expert. So, that's why we're saying that. That's not something that usually a thin air and then automatically come to your mind without any knowledge or without any experience. So it's from within a framework. That is, some phenomena is not well explained by the current thinking. So new hypothesis is often just an adaptation of an existing hypothesis. So that's why we have thesis, antithesis, and synthesis. That is, we have, first of all, we have a thesis, and the thesis that lead to antithesis, and then the antithesis that go are they being developed into synthesis. So now we need to discuss what is meant by the thesis and how it lead to the antithesis and then to the synthesis. So thesis, this normally you do during your MSc or MPhil or PhD. What is a thesis? A thesis is basically the original statement of an idea that you perform or that then you write normally in the form of some sort of the book. I mean this is the original statement. I mean your whole work is focused on that. During that thesis, you develop a problem or statement of the problems. You have an objective, and based on that problem and an objective you proceed towards your proper goal, and at the end you find a solution and that you put in a book like form that we call a thesis. So what is an antithesis? An antithesis is an argument to challenge a previous thesis. Now let's suppose we have someone who publish a thesis or who do a thesis on a particular idea, and then we have another guy, another researcher who get the same thesis, and he want to check some of the data that's already been given in a particular thesis, and he present or he want to challenge that that's already been in a particular thesis with some new arguments, that is often draws on new data. We get a new researcher, and a new researcher he gets some new data, and the basis of that new data he trying to challenge the previously published or the previously done thesis. So that we call antithesis. Anti in the sense that he's trying to target the previously done work or the previously developed idea. And third, we have synthesis. So, what is synthesis? Synthesis as a new argument from existing sources. I mean, you have existing sources, and from that existing sources, you develop a new argument, and that new argument we call synthesis. So, typically, what actually you do typically resolve the apparent contradictions between a thesis and an antithesis. So in short, what is synthesis? So normally, you know that there we have some apparent contradictions between the thesis and antithesis. And antithesis, these apparent contradictions, we basically try to resolve. Um, and the synthesis. In synthesis, we normally trying to do something that is to resolve the apparent contradictions between a thesis and antithesis. These two things. In antithesis, we challenge um, the thesis by with the help of new data or with the help of a new idea. And synthesis is actually what we do to resolve or to give us solutions for the apparent contradictions between the thesis and antithesis. So then we do the testability. I mean, a good hypothesis, you know that it is testable. You have a good hypothesis, so that hypothesis, I mean, you normally proceeded for to give a test or to perform a test on that. So a good that's why we're saying that a good hypothesis is testable, not provable in the sense of shown to be true. Reputation of a thesis by providing that it is false and a cornerstone of modern science. So be remember that, I mean, sometimes it's not true. Maybe, I mean, your guesswork, or maybe what you're trying to do, I mean, it's not been developed on the way by which the thesis has been written. So simply repeating a hypothesis is okay, but better science will explain why hypothesis is wrong. I mean, that this is a key point for our concerns. And open an alternative hypothesis. That's why we always have an alternative hypothesis. So, I mean, the thing is not so simple as it might look. That's why, I mean, you know that sometime, I mean, you at undergrad levels, you are being sent to the lab, and you're asked to perform the work. So here we get a question in mind that normally we ask, that you have wondered. I mean, at undergrad levels, you are being sent to the lab and you are asked to perform a particular experiment. You already know the answer for that experiment. So have you ever think with yourself that why we do the experiment at school or undergrad level, the results of which is known beforehand? I mean, at school or college or undergrad levels, we are being sent to the lab to perform certain experiments, the result of which is already known. So have you ever asked that why we are doing such a piece of experiments? So you better ask yourself that why you were doing that kind of experiments. So let's come back to the hypothesis. We have one or two tail hypothesis. So our experimental design may make either a strong predictions about the behaviors we expect to observe, that is, our manipulation of the independent variables will cause a specific change in the dependent variables. That is, a prediction about a change of behaviors we expect to observe, typically perhaps two. So what are these two? One tail hypothesis. What is mean by one tail hypothesis? So one tail hypothesis has statistical significance. I mean, expected result was found. I mean, one tail hypothesis. What is mean by one tail hypothesis? It means that the statistical significance expected result was found. I mean, in such a hypothesis, we believe that what we were trying to obtain from a particular idea, that has exactly been found. And what is mean by two-tail hypothesis? It means that only need to show that the different results are statistically significant. So this is the difference between the one-tail hypothesis and two-tail hypothesis. That is, at the first we believe that the expected result was found, particularly when we are trying to do the analysis, and that analysis is of statistical significance. At the second, we said that this test only need to show that the different results are statistically significant. I mean, in the second tail, that is in the two tail hypothesis, uh, I mean, we show some sort of the difference, different results, where we say that the statistically that the results are statistically significant. So you know that, as we already mentioned, that to test or to develop any hypothesis, normally we need variables. So the experimental measures, the experiments measure the behavior of dependent variables. So dependent variable must be operationalized. Some aspect of the dependent variable must be measurable, and you better to know uh, what to measure and how to measure. I mean, you will do some measurement, in order to find the result to check the hypothesis. So you better know what to measure and how to measure. And are you really measuring what you think you are measuring? I mean, that is the thing you have to look for. I mean, first of all, you should ask yourself, I mean, what to measure, how to measure, and are you really measuring what you think you are measuring? So these are the questions whenever when you are dealing with a variable. So you better to have them in your mind, and better to ask them and to clarify with yourself. So based on that, we have quantitative versus qualitative research. So what is mean by qualitative and uh, qualitative research? So quantitative research is systematically observed, and quantitative research, we systematically observe changes in the phenomena of interest while manipulating what are believed to be casual influences. I mean, that is what we do in the uh, quantitative research. So, what is qualitative research? So, in qualitative research, may be more concerned with the individual's personal experiences of the problems under study. I mean that's you should differentiate for yourself. That is what we do in the quantity, and what we do or what we expect in the quality. So in quantity, that is in quantitative research, systematically observe changes and phenomena of interest. I mean, in quantitative research, we observe changes and the phenomena of the interest while manipulating what are believed to be casual influences. So what we do in the qualitative research, so we remember qualitative research, I mean, it's concerns with the individual's personal experiences of the problem under studies. I mean, that is it's a kind of research, it's a kind of field where we're trying to I mean, proceed toward the quality, or maybe towards the refinement. I mean, he do excessive work, and based of that excessive work and excessive experience, he trying to refine the solution to a particular problem. So we get approved by demonstrations, that is intuitive alternative to the classical scientific methods, uh, that is build something specific and then claim that it can be seen as an example of a more general class of solutions. So high risk, difficult to demonstrate generalizability. In fact, doing so entails making a posteriori hypothesis. So what can you say if it goes wrong? So you still need a theoretical basis for what you have guessed or for what you have hypothesized. So you have to do a lot of planning whenever you're trying to do a particular research. So first of all, you need to have a statement of the problem. When you have a statement of the problem, so you move toward the literature review to check for whether there are people who have already done the work on that. Maybe if not fully, maybe they have done work on part, or maybe some specific portion of that problem, so you can get their permission and thesis. I mean, you may not get all the thing at once, but maybe you can get the things or the answer, and that answer may be in the pieces, so you better collect them and utilize them according to your own requirement. Choice of research methods means when you collect the data, the background information. So you also define a methods from that the knowledge you collected from the literature review. So you design your study, and based on that design, you collect the data. You start collecting the data. Once you collect the data, you trying to analyze that, and after the analysis you trying to write up those data. So that's all we have for this lectures. In the coming lectures, we will discuss all these parameters that we have in here for carrying out a successful research work. I hope you enjoyed the lecture. Thanks a lot for watching. See you next lectures for further research related problems. So till then, bye bye.